I just want to do a quick review for everyone about Sig Fig so that you're ready for your test. So when you're adding and subtracting things, you actually don't have to worry about counting Sig Figs at all. No counting, no worrying about them. Most of the time you won't see them in this vertical format, but that's the format that will help you remember what to do. You know, most of the time on a test or something, you'll see it and it'll look like this. And maybe it's just because they're trying to confuse you. But I recommend every single time rewriting them like this whenever you have addition or subtraction, because it reminds you what to do. So all you need to do is just find the number that has the shortest position, in a way, is how to think about it. So this one only goes to the ones position. So you pull that line down, and this is how far over your number should go. This guy is going to tell you whether or not you should round. So the answer to this one would be 214, because there's a 5 over there. I'm going to do it again right here. And again, this guy would tell us if we have to round, but we don't because it's a 0. So the answer to this one is 33.0. Draw this line down. And again, this guy would tell us if we have to round. And notice that you don't have to round because it's a 0.4. So the answer to this one is 5457. Again, draw that line down. This is what would tell us to round, but notice it's not higher than 5, so we don't. And then again, I'm drawing the line down, and there's nothing over here. I could put a 0 there. You'll notice though, when I put a 0 there and I bring it down, it still leaves me in this position. So the whole idea is that right here, that's what's limiting the math. This thing is what's limiting the math. So I'm just like looking to see who's the farthest over. This one is limiting the math. This one's limiting the math. And this one's limiting the math. So I hope that makes more sense about addition, subtraction. Like you're just looking for the kind of the shortest place value, and that's where you're rounding the answer to. And that vertical line for me, that's my visual that it really helps me with. So for multiplication and division, what I do in this case is I do have to worry about counting Sig Figs, but I keep them in this like horizontal kind of a format because wherever possible, because it kind of helps me remember what I need to do. When I have that vertical format, then I remember, oh, I need to find the shortest place position. When I have this horizontal format right here, then that's my reminder that I'm going to be looking for the shortest number of Sig Figs. So when I count these guys, anytime it's like this, you do have to count Sig Figs. So this one has 1, 2, 3, 4, 5. So that has 5 Sig Figs. And then this one has 1, 2 Sig Figs. So my answer is going to have 2 Sig Figs. 1, 2 Sig Figs. I can only do it with those two numbers. So what this becomes is 2, 2, and then everything else has to just be 0, 0. This throws people off because what they'll try to do is they'll just try to put down 22. And you can't do that because no one would ever round 2200 down to 22. So I did this particular problem because I know this is an issue. So make sure I know that I only need 2 Sig Figs. Remember, I don't have like a little decimal. If I'd put a decimal there, all of a sudden that makes those little zeros significant. But there's no decimal there. And so that means that those zeros aren't significant. They're just placeholders. Okay, so I'm going to do this next one. And it has a 0 in it that could throw people off. So 1, 2, and the 0 to the right with a decimal counts. It has 3. Look, this second number is with a decimal, but the 0 isn't on the right, so I don't count the 0. That's on the left. It's just the zeros on the right with a decimal. And so that has 1 Sig Fig. So this answer needs to just have 1 Sig Fig. 1 Sig Fig. Notice, like up here on this other one, you know, the 2 would have influenced him, but the 2 is below 4, you know, and below 5. This guy does have a number above 5, and so I need to round him to 4. And that gives me my 1 Sig Fig. Like up here I had 2, this gives me 1. Now in chemistry, it's more likely you're going to see something more like this next problem where you have like some things you're doing all at once, and that's okay. As long as they're all multiplying, all dividing, or a mix of multiplying and dividing, then you just do it like this, the same kind of way. So this has 2 Sig Figs. Remember, zeros in the middle count. 1, 2, 3. And the lowest zeros also count. So that's 4. So again, my answer needs to have 2. So 1, 2. Notice this isn't going to round anything up. It's a 0. So I'm just left at 1.1, and that's 2 sig figs. So that's the summary. So I do have people ask me, how do you do it when you're dealing with factor label method? So you'll have seen this by this point. These are factor label things. And here's how you think of it. The first one that we're doing right here, this is all in the metric system. And we use this kind of special word that is exact. And if something is exact, that means that we can ignore it. So all conversions within metric system are exact. And if you're trying to count for sig figs, you don't have to count this one and you don't have to count this one. You have to use them for the math, but you don't have to count them for sig figs. So I just say this has 1, 2, 3 sig figs. And so my answer should have 1, 2, 3 sig figs. And that's how I leave it. I don't worry about sig figs on this at all. This is just a placeholder position. We just we leave it right there. This is not giving us any sig figs. There's no decimal in there to give us sig figs. It's just telling us we got a whole lot of zeros after that number, right? So then the second example, we have that same kilometers, but now we have some numbers that are not exact. So we know this first one's exact because that's all within the metric system. And this next one, we're switching between systems. So here's my little hint. Most of the time, I would say 95% of the time, when you are using things that are within different systems, like metrics to English units, these kinds of situations, they are going to be to way more decimal places than your initial number. Because your initial number usually comes from measuring something with a ruler or using a scale, and you just don't end up with that many sig figs usually when you're doing it. So most of the time, these middle numbers are going to not matter. But we'll go ahead and count this one. So 1, 2, 3, 4, 5, 6, 7. So do you see how this has 7 sig figs compared to this guy over here? That's why I said it doesn't matter, because it has way more sig figs. And so you can just glance at it and be like, oh, that has way more. I'm not going to worry about that one. And then there are some conversions that are exact. There's exactly this many feet in a mile. And that's between two different systems. So there are some that are exact. Even in this case, though, I could either say, oh, this is exact and it doesn't matter. Or if I was going to count it, it gives me 3 sig figs. So I have 3 sig figs and 3 sig figs. So my answer needs to have 3 sig figs. 1, 2, 3 sig figs. And then this guy does not round him up. It doesn't round him up. So my answer would be 11.5 feet. Oh, sorry, times 10 to the third feet. And let me do another one. Let's do it with if you get something off the periodic chart. And the periodic chart numbers on the chart that you have, you're supposed to be using the chart that goes to 2 decimal places. In real life, remember that chart can go to even more decimal places because they keep being more and more precise in the measurement of atoms and of different masses of different elements. So right here, this is showing to these 2 decimal places, and he's got 4 sig figs. And I will tell you, most of the time it just happens to work out that when you're getting the numbers off the periodic chart, they end up being longer numbers and they don't matter for the sig figs. Yeah, it just most of the time works out that way. You'll notice that this has 1, 2, 3 sig figs. But even if not, you can do a quick check on that one. Some people like to call these exact also. They'd be exact if you had every single little decimal place in them. And then over here, this guy actually has more numbers. If you look it up, there's way, way, way more numbers. But notice if we use this again, this has 4 sig figs. It still doesn't matter because this guy had 3. Your final answer needs to only have 3. So 1.06 times 10 to the 23rd. So I'm hoping that's helpful. One last comment on all of these. Notice that the 1 in all of these little cases, the 1 is an exact amount. We're saying in exactly 1 mole, not 1.2 moles, not 1.6 moles, but in 1 mole. So that number itself, we can ignore also for sig figs. So That's almost always true. The only time you wouldn't be able to ignore the number 1 in these kinds of setups where you're using factor labels, the only time would be if you actually literally measured something to like exactly being just the 1 meter, and you actually measured this like with a ruler or something. You'd have to have measured this. All these factor label things, these ones in here are exact. So I hope that helps. A general rule of thumb, if you're confused, and I found helps a lot of people, is that you should know that it would be really unusual if you had an answer with 1 sig fig in chemistry, because we don't want people to accidentally get the right answer by guessing it. So it's really unusual that we're ever going to set up a problem that has 1 sig fig. So always be aware of that. If you get an answer and it's like 1 sig fig, go back and double check yourself. The other thing is that a lot of the time, and this is not a hard, fast rule, but let's just say you get confused or something. If I were to be making a guess, I would guess my number of sig figs at the end based on how many of this initial number that I had. So that's just like a guessing tip. Doesn't work every time, so don't count on it working every time. But it seems to help people if they feel like they're in a little bit of confusion about it all. Last topic. What do you do when you have equations that mix addition and subtraction and multiplication and division? So there's this thing called PEMDAS. That's the little an acronym to help you remember what order to do things in. And the P in this is parentheses. You're supposed to do parentheses, then exponents, then multiplying / dividing. That one doesn't matter as much. And then addition and subtraction. This is the key one that you have to remember in chemistry. In this section of chemistry is parentheses first. So as we're looking at this problem right here, we have Celsius and we're converting it to Fahrenheit. So the limiting factor on this is how well our thermometer works. So does our thermometer measure to more than 1 decimal place? That's what is limiting on this problem. And this number is going to get plugged in here. And then this 5/9, so this is considered an exact conversion to get between Fahrenheit and Celsius. It's not like it's a measured number. Like it's like in that case of the meters, you get between meters like with an exact conversion amount. This is an exact conversion amount. So we can ignore the 5/9 for counting for sig figs. So I've got an example, plug this in. And remember, it's easy to see this if you write it over here to the side like that. So you'll notice that so if you only were doing that step, then the answer would be 2. But look, we're doing some more math. We're still doing math here. So you can't stop and round after every step. It will mess up your math and you'll get the wrong answer. So how do we handle it? We just make a note of it as we go along to ourselves. So I'm going to make a little note that this answer gives me 1 sig fig. And I know over here that this number right there, it doesn't matter for counting sig figs. So when I do this final math, I have 5/9 times 1.5. So 5/9 times 1.5 gives me this number over here on the right. Giving this answer 1 sig fig stops me here. So the correct answer to this problem is 0.8. What if I had put it in as that 2? Like I would have said, hey, this right here, this rounds to 2, and that's 1 sig fig. So what if I had done that? I would have done 5/9 times 2 gives me 1.11111. And giving it 1 sig fig gives me 1. This is the correct answer. That is not. You see how they didn't work out to be the same? That's why you have to be really careful about doing this. Don't round early. This right here is rounding early. You can't round early. Just put all the numbers in, keep them in your calculator, do the math, and put all those numbers in, but make a note to yourself, 1 sig fig. And so that you know at the end, the answer you end up with is 1 sig fig. So in this last example, this is another kind of equation you might get in chemistry that mixes multiplying and addition subtraction. So on the top we've got subtraction. These absolute values are you're gonna treat those absolute values as though they were parentheses. So you're doing what's in the parentheses first and then divided by a number down here. Note, when you multiply by 100%, that doesn't count towards sig figs. 100% doesn't count. Over here, I've got what to plug in. So, of course, for your t, you're plugging it in there and there. And then this guy goes in the other position. So we do this math right here. And again, we're doing what's inside that absolute value, which is like saying inside a parenthesis. So what you're going to do is we're going to make it to the shortest position. And so that's going to give us 2 sig figs. Now remember, again, don't round at this point. Keep the whole number in there, but make a note to yourself like I made right here that this is going to be 2 sig figs because you did math for it. Now we're going to be dividing by the other number, which has 1, 2, 3, 4 sig figs. And the 100 does not count. You're going to not worry about that 100% for sig figs. So our final answer needs to have 2 sig figs. And notice that the 8 is going to round him up, so that gives me 1.5%. And that's my answer. Hopefully this helped. You're not going to have a lot of cases of mixing, multiplying, and subtraction and addition, and you're not going to have a lot of mixed cases, but I just want to show you those 2 cases where you do have that.